Hello, in this video, we're going to be looking at lesson 9.3, Composite Figures. The essential question that we'll be answering is how do you use the area addition postulate to find composite areas? I'm going to be doing both the day 1 and day 2 portions of lesson 9.3 in this one video. So let's go ahead and get started. First, a composite figure is a figure that's made up of other simple figures, such as triangles, circles, rectangles, and trapezoids. To find the area of a composite figure, you want to break it up into simple shapes and then use the area addition postulate to come up with the area of the composite figure. For example, in this shape right here, you can see that there is a half circle, and then a trapezoid, or I could even break this down into like a rectangle and a triangle. Well, if we can find the areas of the half circle, the rectangle, and the triangle separately using the area formulas for those shapes, we can then find the area of the region by just adding those together. The area addition postulate tells us that the area of the region is equal to the sum of the areas of its non-overlapping pieces. So you do have to make sure that when you're dividing up your composite figure, none of your pieces overlap, or you'll be double counting the area. In this first example, we want to find the area of the figure and then round our final answers to the nearest tenth if necessary. A lot of times there's more than one way that you can break up the composite figure. This composite figure here is kind of made up of two rectangles. How I decide to divide them is just up to me. So for example, maybe I want to divide them right here into a rectangle and a smaller rectangle, or maybe we want to divide it here like this. I'm going to leave it like that, and then let's go ahead and see if we can break this down here. So that 21 is the length of this full side, and then this is 12 right here. So 12 centimeters right there. So let's figure out the length right here. If the total of that left side is 21, and the section in the rectangle on top is 12, 21 minus 12 is 9. So this piece here is 9, and now we just have two smaller rectangles. So let's go ahead and find the areas of each separately. I'm going to start with the area of the top rectangle. The area of a rectangle is found by using the formula area equals BH, where B is the base and H is the height. Here, I'm going to let the base be this 15 and the height 12. So we take 15 times 12, we multiply that together, and that is 180. So the area of the triangle on top is 180 square centimeters. Now let's do the area of the bottom rectangle. It's the same area formula. Area equals base times height. This time our base is 27 and the height is 9. And 27 times 9 is 243. So the area of that rectangle is 243 square centimeters. Well, now for the shaded area, the area of the composite figure, we need to calculate the total area by adding up the area of those non-overlapping rectangles. So let's take 180 plus 243, and when we add that up, we get 423. So that means the area of this complete figure is 423 square centimeters. Let's try another example. This next composite figure is kind of already broken down into parts for us. You can see that there is a triangle on top, then there's a rectangle in the middle, and there's a half circle there. Let's add some numbers here to our picture before we start breaking it down. So this full length right here is 7.8, and then this little rectangle in the middle is 3. So if we want to figure out the length right here, if the total is 7.8 and one section is 3, just take 7.8, subtract 3, and that makes this 4.8. Also note that in this half circle, the radius here isn't actually known, so we're going to have to figure out what that radius is before we can find the area of the half circle. Let's go ahead and start with the triangle on top. So step 1, area of triangle. And we know that the area of a triangle is calculated with the formula area equals 1/2 BH. And the B and the H need to be perpendicular to each other. This is a right triangle, but see how we're actually missing the B right there? We don't know the base. We know the height is 4.8, and we have the hypotenuse 10.2. So the first thing I actually need to do here is set up the Pythagorean theorem to find the base of the triangle. So we're going to use a squared plus b squared equals c squared. And the c is the 10.2. A and b are the other two sides. So 4.8 squared plus b squared equals 10.2 squared. And then you can actually just go to your calculator and type in 10.2 squared minus 4.8 squared. And then your calculator will do the whole thing in one and give you b squared equals 81. Then we just need to undo the squared with a square root. So the base is 9. So let's add that to our picture here. The base is 9 feet. So that is this full distance right there. And now we can calculate the area of our triangle. Area equals 1/2 times the base, 9, times the height, 4.8. Just type that into your calculator, and when you do that, you are going to get 21.6. So that's the area of the triangle. Let's move on to the area of the rectangle in the middle of our composite figure. All right, the area of a rectangle is just base times height, and the base of the rectangle is the same as the base of the triangle, 9, and the height is 3. So 9 times 3 makes 27 square feet. Then for the final shape here, we need the area of the half circle. The area of a full circle is area equals pi r squared. For a half circle, we just need to divide that area by 2. Also note that the radius, I don't have it yet, but I can find the radius because the diameter of the circle is 9. See how the diameter just matches up with this? And if the diameter is 9, the radius is just half that. 9 divided by 2 is 4.5. So we would have a radius of 4.5 feet. And now let's plug that into our equation. So pi times 4.5 squared, and then we'll divide that by 2. When you put 4.5 squared into your calculator, you'll get 20.25. And then the pi is still there. We'll divide by 2. So 20.25 divided by 2 is 10.125 pi. We're going to want to round the final answer to the nearest tenth. So we can actually just convert that by using the pi button on our calculator. So I'm typing 10.125 and then hitting the pi button. And the calculator is giving me 31.808. We can round that to the tens place, so 31.8 square feet. And now we have everything we need to come up with the area of the total composite figure. So for that total area, we're just going to add the area of the triangle, 21.6, plus the area of the rectangle, 27, plus the area of the half circle, which is 31.8. And when we add all of that together, we get 80.4. So the area of our composite figure is about 80.4. For my final answer, instead of saying 80.4, I'm going to say approximately 80.4, because to get that value, I had to do a little rounding right here with the pi value. So the total area is about 80.4 square feet. That again is rounded to the nearest tenth. In the second half of this lesson, we're going to look at some composite figures where it might make more sense, instead of adding areas together, to subtract areas. In this first composite figure, notice that the outermost area is a rectangle, and then there's this triangle that's cut out of the rectangle. So to calculate the area of that shaded portion, we can just find the area of the total rectangle and then subtract the area of the triangle. Why don't we start with the area of the rectangle? And when I'm finding the area of the rectangle, again, I am just looking at the full rectangle as if that little triangle piece was not cut out. So we'll start right here. Step 1, area of the rectangle. And the area of a rectangle is just the base times the height. You can see those values are already in the picture. The base is 36 and the height is 18. So 36 times 18 is 648. That rectangle without the triangle cut out would be 648 square meters. But now we need to figure out the triangle so we can subtract that away. So my area of a triangle is area equals 1/2 base times height. And notice that the base of the rectangle and the base of the triangle are the same. So this piece right here that I just outlined in green would be 36 meters. And that's going to be my base. And then the height of the triangle is 9. So we have 1/2 times the base, 36, times the height, 9. And if we type that into our calculator, we get 162. Well, now we have the information we need to find the shaded area. So for the shaded area, we just need to take the area of the rectangle and subtract the area of the triangle. So that's going to be the 648 minus 162, and that is equal to 486. This means that the area of the shaded region is 486 square meters. In this next example, notice that the outer figure is a circle, and then there's a trapezoid that is cut out of the circle. So I'm going to begin by finding the area of the circle. And the area formula for a circle is area equals pi r squared. Notice that in this picture, the 20 centimeters right there is the diameter of the circle. And the radius is just half the diameter. So if we divide that by 2, we get r equal 10. Now we can calculate the area of our circle as just pi times 10 squared. That's 100 pi. And then since we want to round our final answer to the nearest tenth, we can just type 100 pi into the calculator and get that decimal approximation. When you do so, 100 pi is 314.159. ... Again, I'm rounding to the tenths place, so that would be like 314.2. So that's the area of our circle. Now let's go ahead and calculate the area of the trapezoid. The area formula for a trapezoid is area equals 1/2 times the sum of the bases, so B1 plus B2, times the height. And the bases are the two sides that are parallel to each other, and the height is the distance between them. So here the bases are 20 and 12, and the height is 8. So I'm going to go 0.5 times 12 plus 20 times 8. And we can then just grab a calculator and take 0.5 times 32 times 8. And when you do that, you will end up with 128 centimeters squared. So now we have everything we need to get the shaded area. The shaded area is just the area of the circle minus the area of the trapezoid. So we'll take 314.2, subtract 128, and when you do that, you get 186.2, meaning the area of our shaded region is about 186.2 square centimeters. So in this video, you've seen that there are two different ways to find the area of a composite figure. You can either break it down into the areas of separate non-overlapping shapes and then add those individual areas together like we did in example 1, or if it looks easier, you can find the area of like a full shape and then subtract the areas that are removed. Like in this problem, we found the area of the big outer circle, and then we subtracted the area of the trapezoid. So both techniques are good ways to find the areas of composite figures. Thanks for watching, and good luck as you try some problems on your own. Bye.